Problem 59. Find the derivative of arcsine natural log x over x. Since ln x over x is inside the arcsine function, we start out with a chain rule. And recall that the derivative of arcsine is 1 over the square root of 1 minus u squared, and then applying the chain rule times the derivative of the inside. That means for our problem, our derivative is 1 over the square root of 1 minus, and then we're going to square the u, so ln x over x squared, times the derivative of the inside. Now this inside derivative, I see these two are being divided, so we'll have to use the quotient rule. And remember the quotient rule, if we have u over v, and we take its derivative, this gives us v squared in the denominator, and then v times u prime minus u times v prime. In this case, our u is natural log x. V, the denominator, is x. So u prime is then 1 over x. V prime is 1. So when we go to write this out, we've got v times u prime, so x times 1 over x, minus u times v prime is ln x, all over v squared, or x squared. Now we can simplify this a little further. We can reduce those x's to write this as 1 over the square root of 1 minus ln x over x squared. Now here we can reduce these x's and write this as 1 minus ln x over x squared. And here I don't want to deal with this double-decker fraction. I want to get rid of this x we have in the denominator here. So what we'll do is multiply both numerator and denominator by x. When we do this, if we multiply this x through in the denominator, we first need to have this inside of a square root. So x is the same thing as the square root of x squared. So when we distribute this through, in the numerator we've got an x. In the denominator, x squared times 1 gives us x squared. On the second piece, the x squared outside multiplies and cancels with the x squared inside, so we've got minus ln x squared. And then we still have the second part of this fraction, 1 minus ln x over x squared. And now we can reduce this x with one of the x's in the denominator. And so then our derivative is 1 minus ln x, just multiplying these together, over x times the square root of x squared minus ln x squared.